A very good evening to one and all present here. It's my immense pleasure to welcome all the teaching faculty members for Technical Lecture Series 6 organized by Research and Development Cell, Manakula Vinayagar Institute of Technology. Let me introduce about myself. I am Dr. P. Sivashankaran, Associate Professor from Mechanical Engineering Department. The topic of today's presentation: optimization of logistics efficiency for product distribution problem using any logic simulation approach. My proposed agenda for the presentation as listed according to the following sequence: problem objectives. Next, after discussing the problem objectives, we will move over to the introduction concept on logistics planning and management system, then real application in logistics, then a simple methodology using case study shown by a simulation software called AnyLogic package, then results and discussion, then final conclusion about the work, then references from various journals. So these are the sequence of presentation. Now we will go according to the agenda. Before moving to the problem objective, the type of problem domain. So this topic belongs to the field logistics and supply chain management system. So with this, I will straight away start the concept definition. What is logistics? How logistics plays an essential role in today's scenario. So the term logistics that refers to the physical handling of final product, which comes out from the manufacturing industry. Okay, so we need to plan various strategy to safely move the final end item to customer, okay, without affecting the quality of the product. So accordingly, we have to plan the logistics operation very smoothly based on the given time frame. Say for example, there are two cities, say Chennai and Bangalore. So Chennai is the hub source and Bangalore is the destination point. So you want to find out the shortest path uh, in order to transfer all your end items quickly within the given time frame so that the customer's wish can be fulfilled by delivering the better quality product through safe mode. So first thing, we need to fix the transportation path or logistics route between the two cities. So the road should not be congested with the heavy traffic. That is one factor. And the next thing is the condition of the road. Okay, likewise, there are several the factors to be weighed in measuring the efficiency, operational efficiency of logistics. According to the language of operation management, the two phrases, logistics and supply chain, both are mutually interdependent function, integrated with each other. Okay, so logistics deals with the transfer of final end items between manufacturer and customer. Whereas supply chain, so that deals with various production activities between supplier and manufacturer. So when a material is being received by the manufacturer from supplier, so he will stock the material into the inventory. Manufacturer will stock the material into the inventory. From inventory, the material will be flowed to production center in order to transfer the raw material into a final product. So inbound activities which is carried out inside the industry enterprise, we call that as a supply chain management. Okay, the physical flow of material from supplier to manufacturer, from manufacturer to retailer, from retailer to customer. This network, big network, we call that as a supply chain. Whereas logistics that deals only the final positioning of product to the market demand center with a suitable transportation mechanism. Okay, so supply chain management, how that is different compared to the previous slide, the information what I told in the previous slide. So supply chain is a process which manages different functional areas like planning, procurement of raw material for production according to the customer demand, and also supply chain management system takes care of inventory planning and the continuous tracking of inventory in order to measure the current ongoing stock rate of the inventory system from time to time in order to balance the material shortage problem to match both supply and demand situation. Following problem objectives are framed. So in this work, mere attempt has been taken to perform the simulation experiment for logistics operation to measure its efficiency for a product distribution model. What are the physical parameters taken for simulation study in order to calculate the logistics efficiency? Overall capacity of the truck, orders made per hour, number of orders, number of loading and unloading trucks per hour. These are the four important factors I took as a major thing for calculating the transportation efficiency of logistics. Now, coming to the introduction concept, according to the literature survey, so Christopher et al., he has published a paper in the so-called domain area, supply chain and logistics, a literature paper in the year 1992. So, according to the ideology of him, so he has correlate defined supply chain in such a way. It is a large web of a network which has many business players that are intertwined with each other. Say, for example, supplier, customer, retailer, distributor, manufacturer. These are the five number of business players who can effectively participate in transferring a physical raw material into an usable final goods according to the service request proposed by the client. So this is the final meaning of what is supply chain. So supply chain can be understood on macroscopic approach, whereas logistics can be understood on microscopic analysis of study. This is a microscopic function. Following introduction continues in the next slide as shown here. Supporting factors which influence both supply chain management and the logistics function are listed here. Production sites, location of production sites. So check the selection of raw material, availability of manpower. To start an industry, first thing you need to find a land or a location to start a company. Next thing, availability of raw material to process the production, then skilled labor. Likewise, various factors are required to find out the best location of production sites. The next thing, inventory idea, storage idea, and the physical movement of material through proper transportation plan from one end to another end. Then identifying the number of the geographical node in order to fix the distribution center to transship the final end items to various location, and the flow through each nodes, number of visits made between each geographical nodes. So these are the different the factors that are considered in logistics and supply chain management system. Application of logistics. So it is used for effectively for vehicle routing problem like route planning, right? Then fleet management, the capacity utilization of the truck, then network design, logistics network design, the flow process of the material from start to end. Okay. The next thing, analyzing the operational efficiency of the current operation for improving and redesign, for improvement and redesign. So the second point in which I'm going to focus by showing a simulation part, uh, how operational performance efficiency can be uh, compared by different cases. Methodology. Now coming to the methodology. So in this section, the detailed problem is described on logistics in terms of performance efficiency. So the type of tool used here is a simulation tool, name any logic simulation package. So in this case description, 4 illustrative figure models are discussed as shown here. So this is just a 3D simulation animated bitmap image of a warehouse logistics. And these are the different physical dimension, the variables that are shown below the dashboard. So for your clear reference, I have taken all the variables. I have rewritten here for your kind reference. So taken from figure number 4. So what are the variables? Number of material handling, that is forklift. Okay, that is inbound logistics. Then number of docking centers, storage centers, unloading storage centers, number of orders to be assembled, then unloading and loading trucks per hour, which is operated, then orders to be made per hour, then truck capacity, then maximum order size and minimum order size. So out of several parameters, so I selected loading and unloading trucks per hour, orders per hour, and truck capacity. These are the 4 important the variables I selected for evaluating the performance of logistics system. So in the next slide, which gives an equation how to calculate the efficiency of the logistics. So truck capacity divided by number of orders made per hour, then utilization of loading and unloading trucks per hour. So from the given data, substitute the variable in the equation and find out the performance efficiency of logistics as per the illustrative uh, analysis case A. The next second case, the same procedure is adapted just by interchanging the variable dimensions under each column, so which is separately shown here. Say for example, in the previous case A, number of forklift material handling, that is number of forklift is 30 units, that is 30 numbers it is required to physically handle the parts from the storage location to the container trucks in order to drop the items into the container trucks. But here only 22. So from 30 it has been interchanged into 22 units of forklift. Likewise, every other variables are slightly modified, and according to this redesign, so we can able to check the percentage change in percentage efficiency of logistics. So it is very poor compared to the previous case. Likewise, case C and case D, so the logistics efficiencies are calculated. Final results and summary as given in the table. So you see here, when we decrease the capacity of the truck, number of orders and loading and unloading, we can able to get the better output efficiency. But here in other three cases, the capacity is more, but the number of orders and loading truck and unloading trucks are not much higher as per the fixed truck capacity. So it gives ineffective result, right? So in my objective, my problem is to keep the inventory cost fixed by reducing the order size, only 3 orders per hour, then loading trucks 3 and number of unloading trucks 4, then capacity 15. So this was my objective, improving the efficiency, not effectiveness. So by we can able to reduce the travel distance of a truck by very closely locating the source and destination point in a nearby proximity limit, such that we can able to minimize all the resource wastage by keeping the minimum buffer stock depending on the period requirement based on the demand. So this is the statistical bar chart graph according to the previous slide, the efficiency of logistics. Based on this result, a bar graph has been drawn. So among the 4 stages of analysis, so the first one, the case A gives a better yield in terms of performance efficiency through simulation study. So with all this valuable information, finally I conclude that logistics plays an inevitable role in business organization to effectively plan the fundamental resource like material, machineries, equipment, skilled manpower. So starting from the initial stage to the final stage of operation. So here a mere attempt has been made to simulate the warehouse logistics for a product distribution type model using any logic package solver. Based on the simulation result, it is observed from the fact that the truck capacity, number of orders per hour, and the loading trucks and unloading trucks per hour are the highly influential factors which is used to evaluate the percentage efficiency of logistics in transferring the item from source to final destination point. The main objective here, which is considered to reduce the capacity of the truck by minimizing the following the supporting factors so that we can able to achieve the best yield in planning the resource from source to delivery hub. So these are the reference material taken from the web resources. So with this presentation, I thank everyone for giving me the opportunity to share my thought on logistics and supply chain management function for a product distribution problem. This video is a trial, a rehearsal video. The next day we will have an offline presentation through live meeting. So once again, thank you one and all.